Hi y'all, welcome back. I'm Pi and today we're going to be taking a look at problem number 13 from the 2015 AMC 10B. The line 12x plus 5y equals 60 forms a triangle with the coordinate axes. Let me sketch this out right over here. This is going to be my y-axis and this is going to look something like an x-axis. It's a little bit off kilter, but here we go. And I've got this line, 12x plus 5y equals 60. And I want to write it in a y equals mx plus b form, or slope-intercept form, so that I can sketch it out in my coordinate axes. So I'll just do some algebra right over here, subtract 12x from both sides, divide both sides by 5. And then I get y equals 12/5 x plus 12. And I'm noticing this is a negative slope right over here. And this is 12 as the y-intercept. I've got 12. I've got a negative slope going down. So my triangle is this one right over here. And now I want to find the sum of the lengths of the altitudes of this triangle. So what is an altitude of a triangle? Got a sample triangle right over here. I'm going to make it a right triangle because that's what we're working with. And the altitudes of a triangle, actually, let's take a look at something that we don't know is a right triangle, is any side perpendicular to a base or any length perpendicular to a base that runs through the triangle that you can use to find the area when you multiply by half the base. So I'm going to say, if this is my base right over here, then I want a line perpendicular that goes to that angle. And that's going to be this line right over here. Now what if the base is another side? Well then I just want a line perpendicular to that. Going to be right over here. And if this is my base, then it's going to be something like that. In a right triangle, it's a little convenient because I've got, this is my base and I want a side perpendicular to that. Oh, hey, this side's perpendicular, so I can just use another side as my base. So as my altitude. So I'm going to use this as my altitude and I'm going to use this bottom line as my base. And then if I want to take a look at this side now, and I want to say, hey, what's the altitude perpendicular to this? Then I'm going to say, this looks like it's perpendicular. Now, I want to take a look at that last side over here, this hypotenuse, and I want to find altitude for that. Now, this is not as straightforward as just finding another side, because I'm just going to drop a perpendicular all the way down here. So now let's take a look at our actual triangle on the coordinate axes. And I know that I already have the length of one side. This is 12. I need the length of another side. And I need this altitude over here. Now, the length of this side seems like I can actually get it with my line because I notice that it's bounded by 0 on the x-axis and this x-intercept of the line, which is where the line intersects the x-axis. And so that's where y equals 0. So it's going to be of the form something like x, 0. And I want to find that x-coordinate right there because I know that minus 0, or just x, is going to be that length. So let's go ahead and find x using our equation. So I'm going to set y equal to 0, and I'm going to say negative 12 fifths x plus 12 equals to 0. Then I add 12 fifths x to both sides. Oh no, that's equal to that. And then I can go ahead and cross multiply, or I can just take a look at this and say, well, I need to multiply 12 fifths by something so that it becomes 12, and that something looks like it has to be 5. So I'm going to say x is actually 5. And so that gives me this side length. And now the last thing I need to find is altitude right over here, but it looks like that might not be as straightforward, considering it's just not another side. So to understand more about this triangle, I'm actually looking for this side length because that looks like something I can find using the Pythagorean theorem. In fact, I don't even have to really go into the theorem because noticing Pythagorean triples, I know 5, 12, 13 is a common right triangle. So I'm just going to say, okay, one side's 5, one side's 12, this is going to be 13. You can also plug it in by finding the square root of the sum of the squares of the two other sides. So, okay, this is 13, and I'm still waiting for information that'll help me find that altitude. And one way I notice I can do this is by using the area of the triangle. So an area of a triangle is half the base times the height, or the altitude in this case. And I know that no matter what base and altitude I choose, the area of a triangle is always going to be constant. So if I choose this as the base, and this line segment with length 12 is the height, then I can find the area. And then I can use 13 as my base, and I can solve for my final altitude. So let me go ahead and do that, and I'm going to say that 12 times 5 times half is going to be 30. So then I say that's 30, and I'm going to multiply 30 both sides by 2. And I get 60 over 13 as my final height. Now I actually need to find the sum of the lengths. So I need to add up 12, 5, and 60 over 13, my bad. But I don't even really have to calculate because this is an AMC 10 problem, which means I can first take a look at my answer choices to see what's even reasonable. I could calculate it, but I know that if third altitude is going to be 13, then I'm actually going to put everything over a denominator of 13 before I add. And I notice this is the only answer with a denominator of 13, so I'm going to circle option E. If you go ahead and expand it out and you say 12 plus 5 plus 60 over 13, you are going to get 281 over 13. Feel free to try it on your own. Thank you all so much for watching. I will definitely take a look at any comments or any questions you have to address them, and I'm happy to do problems like the AMC, the AME, math counts, etc.